Have you ever noticed how people react when a rainbow suddenly appears in the sky? Someone points, another grabs their phone, and for a moment everyone looks up together. It's one of those rare sights that still manages to amaze us, no matter how old we are. But if you think about it, a rainbow is a strange thing. It looks solid enough to point at, yet you can never reach it. It appears after rain but vanishes quickly, and somehow it paints the sky with perfect bands of color. So what exactly is a rainbow? Is it something floating in the sky? Is it light? Is it water? Or is it just an illusion? Today, we'll explore the fascinating science behind one of nature's most beautiful phenomena, the rainbow, and understand how sunlight, water droplets, and a little bit of physics come together to create this magical arc in the sky. Right here on History of Simple Things. At its core, a rainbow is simply the result of sunlight interacting with water droplets in the air. When it rains, millions of tiny droplets remain suspended in the atmosphere. Each of these droplets can act like a tiny glass prism. When sunlight enters them, something interesting happens. Instead of traveling straight through, the light bends. This bending of light is called refraction. When sunlight passes from air into water, it slows down and changes direction slightly. But the story doesn't end there. Inside the droplet, the light reflects off the inner surface of the water and then bends again as it exits back into the air. This combination of refraction, reflection, and refraction again is what creates a rainbow. But there's another important detail. Sunlight isn't just white. We often think of sunlight as plain white light, but in reality, it contains many different colors mixed together. These colors include red, orange, yellow, green, blue, indigo, and violet, the familiar sequence many people remember with the acronym ROY-G-BEAV. Each color of light has a slightly different wavelength. Because of this, each color bends at a slightly different angle when it passes through water. This process is called dispersion. When sunlight enters a raindrop, the colors separate. Red bends the least, while violet bends the most. By the time the light exits the droplet, the colors have spread out into a spectrum. Now imagine millions of droplets doing this at the same time. Each droplet sends a tiny beam of separated colors toward your eyes. When enough of these beams reach you, they combine to form the arc of colors we call a rainbow. One of the most recognizable features of a rainbow is its curved shape. But why does it appear as an arc instead of a straight line? The answer lies in the angle at which light exits the raindrops. For a rainbow to be visible, sunlight must enter the raindrop and bounce inside it at a very specific angle. For red light, this angle is about 42 degrees from the direction opposite the sun. Violet light exits at about 40 degrees. Because of this geometry, the colored light that reaches your eyes forms a circular pattern around a point directly opposite the sun. From the ground, however, we usually only see the upper portion of this circle, which appears as a graceful arc across the sky. If you were high enough, say in an airplane, you might actually see a complete circular rainbow. Pilots and skydivers sometimes report seeing full rainbow circles surrounding the shadow of their aircraft on clouds below. There's a simple rule for spotting a rainbow. The sun must be behind you. If you turn your back to the sun while rain or mist is falling in front of you, you may see a rainbow forming in the opposite direction. This happens because the light rays creating the rainbow are traveling from the sun into the raindrops and then back toward your eyes. If the sun is directly overhead or in front of you, the geometry doesn't work. The angles needed for the rainbow simply can't line up. This is why rainbows are most often seen in the early morning or late afternoon when the sun is lower in the sky. Here's something surprising. No two people ever see the exact same rainbow. Even if you're standing right next to someone else, the rainbow you see is technically different from the one they see. That's because the rainbow depends on the specific droplets sending light directly to your eyes. A different observer will receive light from a slightly different set of droplets. In other words, a rainbow isn't really an object in the sky. It's more like a personal visual experience created by the interaction of sunlight, water droplets, and the exact position of the observer. This also explains why you can never reach the end of a rainbow. As you move, the geometry changes and the rainbow moves with you. Sometimes, if conditions are just right, you might notice a second rainbow above the first one. This is known as a double rainbow. The second arc forms when sunlight reflects twice inside the raindrop instead of just once. Because of this extra reflection, the colors in the second rainbow appear reversed. Red is on the inner edge instead of the outer edge. The second rainbow is also much fainter because each reflection causes some of the light to escape, reducing its brightness. Between the two arcs, there is often a noticeably darker band of sky. This region is called Alexander's Band, named after an ancient Greek philosopher who first described it nearly 2,000 years ago. Rainbows often appear especially vivid right after a heavy rainstorm. This happens because the atmosphere is usually cleaner after rain. Dust and pollutants are washed out of the air, allowing sunlight to pass through more clearly. Additionally, the lingering raindrops in the air provide countless tiny prisms for the light to interact with. The combination of bright sunlight and fresh droplets creates ideal conditions for a brilliant rainbow display. Sometimes, if the droplets are extremely small, like in fog, you might even see a fog bow, which appears as a pale white rainbow due to the way tiny droplets scatter light. Long before scientists understood the physics of light, rainbows captured the imagination of people around the world. Many cultures created myths and legends to explain them. In Norse mythology, the rainbow was believed to be Bifrost, a glowing bridge connecting Earth to the realm of the gods. In Irish folklore, rainbows famously mark the hiding place of a leprechaun's pot of gold. In other traditions, rainbows symbolized peace, hope, or a message from the heavens. Even today, the rainbow remains a powerful symbol across cultures, representing diversity, beauty, and the idea that something wonderful can appear after a storm. Perhaps that emotional connection is part of why rainbows still feel magical, even when we understand the science behind them. So the next time you see a rainbow stretching across the sky, remember what's really happening. Millions of tiny droplets are bending, reflecting, and separating sunlight into its hidden colors, sending those rays back toward your eyes at just the right angle. It's physics, yes, but it's also one of the most beautiful demonstrations of how simple natural processes can create something breathtaking. And that is exactly the kind of wonder we love exploring, right here on History of Simple Things. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.